Alrighty, so we are on day 3 of this little mini unit, unit 8, okay? So we are going to talk about dividing rational expressions, okay? So I am working with worksheet 8-3, okay? There's a blank copy attached to the assignment on Schoology, okay? The answer key, all the answer keys are within the Unit 8 to Unit 9 folder, okay, and there's a folder within there that has all the answer keys for all our worksheets for the next 2 units, because they're both very short, okay? So I put them in one folder, all right? So, what is the most important thing to do when multiplying rational expressions? So there, what I want you to see is, first, whoa, can't spell there, oh boy. First, you need to factor, then cancel. Okay. Lastly, okay, you need to multiply across. Okay. So if I take a look here, right, this one is multiplication, right? So I am going to factor whatever I can. So here I have m minus 5, right? Then on the bottom, that's going to be im, okay? So that's going to be, I have to multiply to 20, negative 20, I should say, and add to negative 1. So that's going to be negative 5 and 4. So then that's going to give me m minus 5 and m plus 4. Okay, for those two, that numerator and denominator. Okay, so that. Then, if I take a look here, all right, you may be tempted to cancel this 4m cubed and this 4m cubed, but these are not the same exact binomial factors, so you can't cancel individual terms, so you have to factor these, okay? So if I look at this guy, this is GCF, all right? My GCF, I can take a 4 out of each of the coefficients, and then there's an m squared in each of these. So this will be a 4m squared. And then in the denominator, right, I can take a 4 out of these as well, and an m squared. So that's my GCF for that guy too. Okay, so I'm going to have actually the same GCF for the numerator and the denominator, okay? So when I take those out, I should see the 4m squared outside the parentheses. Then 4m cubed divided by 4m squared is just an m, plus 16 divided by 4 is 4. And then the m squareds cancel out, so I get m plus 4. Then in the denominator, 4m cubed. Okay, so again, I'm taking a 4m squared out. That's going to leave me with an m. And then plus 4m squared, right? If I take that out, that's going to give me a 2, right? The m squareds will cancel. And 8 divided by 4 is 2. So that's my factored form. So now, once I have everything factored, then I can cancel, reduce this. So numerator to denominator, those become 1. Then m minus 5, right? It can be in the same fraction. Numerator to denominator, and same thing here, right? These guys go as well. So then I'm really left with just a 1 in the numerator, and then m plus 2 in the denominator, okay? So remember, if everything cancels in the numerator, you have to put the 1 there, okay? To show that the other expression is in the denominator, all right? So that's our first thing, okay? That's when we multiply. Now, what you're going to see here is when dividing rational expressions, it's almost exactly the same. The only thing you have to remember to do is keep, change, flip. Okay, which I'm going to keep writing, keep, change, flip, okay, just as an acronym, all right? So every time you have division, you have to keep, change, flip. So if you look here, this guy, right? These are all division. When we do our review next week, you have to pay attention. If it's division, the first thing you're gonna do is, right, this turns into addition, multiplication. And then I flip this fraction. Let's go like this. Do this. So this goes here, that goes there, okay? So now I have 12x minus 12, okay? Now, if I take a look here, I can't factor 2x squared because that's a monomial. This guy, I'm gonna have a GCF of 15, I can see that, right? Because they both have a 15, so that's 15. So divide out a 15, think about that. That's what you're really doing. So what's that, x minus 1? Okay, remember, when you divide something by itself, it becomes a 1. It doesn't just disappear, okay? Then here I can see there's a GCF of 12, right? So I'm gonna take that out. And then I get x minus 1 as well. And then this is a monomial, so I'm gonna leave that. Now that I factored everything, I can cancel, just like I did. So it's the same exact thing as what we just did last class, okay? So the only thing you have to remember is keep, change, flip. These will cancel, right? And then you're left with 12 over 15, but you may have recognized already, but 12 over 15 is reducible, okay? So I should have probably reduced it at the beginning, but you could do it now, okay? It doesn't really matter. Just make sure you always look to see if you can reduce something at the end. So 12 and 15, those are monomials, right? They're just regular numbers. But what can I reduce that fraction by? A factor of 3, I believe. So this should become 4/5. Okay, and that's our answer, all right? So again, this means I have to keep, change, flip. So I'm gonna have a squared plus 8a plus 15 over a plus 5 times 5 and a plus 3. Remember, I'm gonna keep saying this. You cannot cancel that 5 with this 5 because this is a binomial. These are attached, okay? It's not a factor. So what I'm gonna do here is factor this one, okay? This is IM. So I'm thinking I gotta multiply to 15 and add to 8. So what's that? 15 factors of 50, 3 and 5. So then I'll have a plus 3, a plus 5. That's what that numerator turns into. I can't factor this. That's a monomial, right? Can't factor that. And then a plus 3, can't factor that either. And then what happens? Oh, look at this. So nice. 1, 2, 3, 4. Everything is 1s, right, when I cancel it. So then I just have 1 times 5, which is 5, over 1, which is just 5, okay? So when 1 is in the denominator, as you probably remember, right, you don't have to show it, but if 1 is in the numerator, you do need to show it, okay? All right, so let's look at the last two on this page. Okay, so this one, let's see, this is division, so I'm gonna do keep, change, flip. So 2n squared minus 10n over n plus 3 times 2n, okay? You cannot cancel this 2n with the 2n squared. However, if you want to, these are already common factors that will cancel, so you can cancel those right away. That's just 1 and 1, okay? Then you can, or you can do that in the second step. It's up to you, all right? I just want to make you aware in case you're wondering. This one, we have to factor, so I'm going to do GCF of what, 2n? Yeah, because I could divide a 2n, and each of them have at least an n. So 2n, divide that out, I am left with an n minus 5 over 1 times 1 over 2n. And now, since I pulled the 2n out, that's a factor. I can cancel those two, so then I'm just left with n minus 5 over just 1, right? Which I don't have to show like we talked about. So it's just n minus 5. All right, then this guy, put a star next to it because it's a little tricky. Remember, we're going to keep, change, flip. So on the homework, the big thing that you have to remember is keep, change, flip. Then we're gonna follow the same steps as multiplication, okay? So then we just factor, cancel, and then multiply across. So this is n squared minus 5n plus 6 over 4 minus n squared times n squared minus 4 over n minus 2. Okay, so hopefully that you recognize this as IM, or trinomial, however you want to call it. And so you're multiplying to, and you don't have to necessarily show me this, I keep showing it, but this is what you should be thinking, okay? So what multiplies to 6 and adds to -5? It's got to be -2 and -3, right? So be careful there. You can't use 6 and 1 because you need it to be positive. So both of these have to be negative. So this should be n minus 2 and minus 3. Then, if I look at this, you have to recognize that this is difference of perfect squares because there's two terms, it's subtraction, and then they're both, there's only two terms, and they're both perfect squares, okay? So this is DPS, okay, difference of perfect squares. So remember, we take the square root of each, so the square root of 4 gives me a 2 and a 2. The square root of n gives me an n and an n, and the only difference is a plus or minus, okay? And I multiply, and then you'll see this is exactly the same, right? This is DPS, except when I take the square root of n, that's my first term. The square root of 4 is 2 and 2, and the only difference is their signs. And then this is n minus 2, okay? Now, if I look at this one, okay, I can see right now, to me, these two cancel, okay? Now, if I use that n minus 2 to cancel with this factor, I cannot use it to cancel with that factor as well, okay? So once I cancel something, it's already been canceled, all right? I've reduced it with this binomial factor, so I can't use it for that one. However, I do see, oh, and then I see n plus 2 and 2 plus n. Does it matter what order you add things in? No, it doesn't, right? So if you think about like 3 plus 2, that's 5. 2 plus 3 is 5 as well. So the order in which you add things doesn't matter. So these are the same factors. However, hopefully, and this is going to show up on the homework, and it did yesterday too, you recognize that these are opposite factors, right? Because the order in which you subtract things does matter. But if you remember what we talked about last class, if I have n minus 2 and 2 minus n, so it's subtraction in the opposite order, those are opposite factors. So when I cancel them, I just give them opposite signs. So this will become 1, and then this will become -1, okay? So you just, and I always make the numerator, you don't have to make the numerator, but I always do, okay? It's just easier when the negative is on top. So now I get -1. This is a positive one. Opposite factors get opposite signs when you cancel them. So what I'm left with in the numerator is -1 times n minus 3, okay? And in the denominator, everything canceled, so that's 1. You can leave the answer like this, or if you want, you can distribute that -1. So if I distribute it, it becomes -n plus 3. Either one is fine with me, okay? You don't have to distribute there if you don't want to, okay? So that's our first few examples. The last one isn't that bad, okay? We have one more. So now if I look at this guy, right, I'm gonna do keep, change, flip because of the division, okay? Get rid of all that. That's your homework, okay, the rest of the worksheet, all right? But here what we're gonna do is n minus 1 over n squared plus 4n plus 3 times, then I'm gonna flip this guy. And then I'm gonna have n squared plus 3n minus 10. Okay. So now if you look, like I did in one of the previous examples, can you see this trinomial is exactly the same as that trinomial? So if that happens, they're gonna have the same factors. So I can cancel those right away. I don't even have to factor them. but the catch is they have to be exactly the same, okay? So those two can cancel. Then I'm left with n minus 1 over 1 times 1 over, and then this one, right, I have to factor using IM. So you have to think about what multiplies to negative 10 and adds to 3, which I think would be 5 and negative 2. Yeah, that makes sense. Yeah? Okay. So then I get n plus 5 and n minus 2. Okay? And then I look. Well, annoyingly enough, I worked very hard to factor that, but none of the factors match up with the n minus 1, so I'm just going to write it as n minus 1 over n plus 5 times n minus 2. I'll leave it in factored form, and there's your answer, okay? There's nothing really there you can do, okay? So we'll just leave it like that, and that's our final answer, all right? So big thing to remember, okay, is our steps here for division, okay, are gonna be, so things to remember, right? You're gonna do keep, change, flip. Step 2 is factor. Step 3 is cancel, right? Reduce it by its common factors. And then step 4, I should say, is multiply across. Okay? So very similar to what we did yesterday, just make sure you pay attention to the sign in the middle when we do some review. All right, guys, have a good one. All right, and I will hopefully talk to you all soon.